Very good morning to all of you. I hope that I'm audible.
Yes, we can hear you.
Okay, thank you, sir. Warmly welcome my teacher, Professor, Emeritus Professor Priyan Dias. Thank you very much, sir, for accepting our invitation. Today, again, we are starting our sessions on certificate course on scientific writing. And today is the fifth session. The title is Using Prior Knowledge in Research. So we invited our Professor Priyan Dias to deliver this lecture because I thought that he is the best person to tell you, to address you regarding this. So, dear sir, thank you very much once again. And cordially invite Ms. Manti, Engineer Manti Karnaratne to let you know, express your Professor Priyan's biography. Okay, Manti, please.
Thank you, Professor. Good morning, everyone. It is with great honor I introduce you, Emeritus Professor Priyan Dias. Professor Priyan Dias is an Emeritus Professor attached to the Department of Civil Engineering of University of Moratuwa and Professor at Sri Lanka Institute of Information Technology. He has a BSc Honours from the University of Sri Lanka, PG Diploma from Imperial College of Sciences and Technology in London, and a PhD in Concrete Structures from University of London. He obtained his fellowship of the Institute of Engineers Sri Lanka in 1998 and is a chartered engineer at Institute of Structural Engineers UK. He was the founder director of research at University of Moratuwa, a member of National Research, and an associate editor of Civil Engineering and Environmental Sciences. He is currently the president of the National Academy of Sciences of Sri Lanka. Currently, his field of interest include philosophy of engineering and engineering design, concrete structures and technology, application of artificial intelligence techniques, and thermal creep of hardened cement paste. So, dear sir, over to you.
All right. Thank you very much. So it's my turn to ask whether I can be heard. So I suppose I can be heard, right?
Yes, sir, you are. Right.
Yeah. Okay. So this is the topic that I was given. Right? I hope you can see my screen and everything. I will put the pointer as well. So this is a rather unusual topic, right? I mean, for example, Moratuwa University has a research methodology course. I don't think we actually cover this. I mean, there is a section on literature review, right, which has been covered, but this is a rather unusual topic. So I didn't ask the organizers what exactly they wanted me to do, because that way I could be a bit free in deciding what I could do as well. So anyway, what I want to do is to put some ideas together, and then hopefully this will be of some assistance both in the actual performing of research and also in the writing up of research, because this is about scientific writing. Okay, you see. Okay, so I want to talk about this slide a bit, because this is I don't know how relevant this is to prior knowledge, but this is something that I used to introduce to first year civil engineering students at Moratuwa University. So this has been in my the background of my mind also, and it tells us a little about what we try to do in research. Okay, so I have captioned it data to wisdom, from data to wisdom. And very often this is what we do in research. So the world, of course, is a very messy place, right? The world as we experience it, from the time that you're a child and things like that, we don't really study the world naturally, right? We just live in the world, right? And there are some ideas we have about the world, both scientific and cultural and sociological and things like that. If you want to study the world, you have to take a slice of it. That's called abstraction. The moment you do that, you have data. Or if you want, you can say, you know, in order to get data, you have to take a slice of the world. So in a sense, you are sort of like doing violence a bit to the world. The world, what you get from this slice is not exactly what the world is, but you know, it's still some very useful information about the world. Now, data is very important for research and things like that. You know, this, I mean, already the past decade and this decade, I mean, we are supposed to be in a data-centric environment, right? And this is supported by a lot of computing power and things like that, where large amounts of data are available, can be captured. If you write a journal article, for example, people will ask you, you know, will you be happy to share your data? There are actual journals that are dedicated to just presenting data, right? We have things like the Internet of Things that are, you know, already there in some parts of the world coming, where continuously there will be data recorded about the world. Okay, so data is very important, and data can help us to do research. Okay, but data by itself sometimes does not give us any insight, because it is maybe just a lot of numbers. I mean, data typically is in numbers, but if you think about sociological research, it can be in terms of labels. I mean, data labels, strings of words and things like that. And I will cover a bit of that also. So in order for the data to help us, we have to structure it, right? The moment you structure data, you get information, right? And very often, you know, now, you know, again, there are entire courses, I think, you know, on data visualization. Because there's so much data, you know, you need to be able to visualize, okay? So you have to structure the data, then of course, you can get some information. But to get from information to knowledge, you need to interpret, right? And this process of interpretation, you know, takes place when we actually use language, right? Now, engineers, you know, how many of you are engineers? I was told that there were non-engineers also attending this, but the majority may be engineers. Engineers tend not to be very good with words, right? They are good with data, they are good with graphical information, right? But they're not very good with words, and that's a disadvantage. So we need to be able to look at that disadvantage, remember it, and try to make amends for it or mitigate, right? And then once you have the knowledge, you know, if you apply that knowledge, you know, then of course that is wisdom. And then, you know, in the process of applying that, you know, you will make an intervention in the world, which may then change the way the world is, right? And then, you know, once again, you can go on in this loop. So I find this very useful for myself, right? But let's see. I find that, you know, this going to the next slide is a bit difficult. Okay, right. Okay, so now this is some rainfall data, right? So this is still a bit away from my topic, but I think it will be useful in the context of this entire series. Right now, this is about rainfall. So if you look at this piece of information, right, this is called the mean monthly rainfall data. For the month of, okay, let's say this month is what, September, it's 157, right? It does not mean that in September 2022 that we will get 157 millimeters of rain in Colombo. It does not mean that every single place in Colombo over the last 10 years for which this has been averaged has got a mean monthly rainfall of 157 millimeters, right? One part of Colombo. And what is Colombo? Colombo maybe is a city. So maybe it's the urban limits, right? Because there are a limited number of rain gauges that would have been used. But nevertheless, so this is an abstraction, I said, right? This is not what the real world is. This may not be your actual experience of rain, whether this year or even in the past 10 years from which you have got this average, right? But still it is useful, right? It is a number, okay? And similarly, we have for gall and candy as well, okay? So once you have these numbers, of course, you can stick to numbers and still you can get some information. You can get the average, you can get the total, you can get the minimum, you can get the maximum, and all of those kinds of things, right? But if you put it in this kind of graph, then you begin to think that there is actual information here and not just data, right? Now, actually, I was asking Banduni also whether it would be, possible to make this interactive. I don't know how difficult it will be to allow participants to unmute themselves, if they want to interact for the first part of this talk. I don't know, somebody who is, handling the controls or whatever it is, you can have the option maybe to allow participants to unmute themselves if they want to participate, right? Okay, in the first part of this talk, right? Afterwards, I will tell you when, once again, to mute them, right? The reason we mute participants, I suppose, is, because if there is a construction site close by, then we will be hearing the noise from your construction site. But anyway, I'm not sure whether you can unmute yourselves. Now, if you look at this information, how many of you can convert this information to knowledge? Why don't we have 1 or 2 people sharing this? Okay, unmute is allowed, right? If you don't want to talk, you can even put in the chat. Now, what kind of information do you get about rainfall, right? If you want, we can concentrate only on Colombo, which is the blue one, right? Okay. Of course, this meeting is held in Colombo. But anyway, any thoughts about, in words, telling me what this graph is showing? What is it? What does it show? Any idea? What can you say? Don't just tell me this gives you the rainfall, Colombo, Candy, and Gaul. I know it does. But what can you say about it? This is why I said engineers sometimes are not very good in words, right? Shall we make an attempt to make this interactive? Yes, please. Thank you.
First quarter is a dry spell. Therefore, maybe you need more electricity generation.
No. I don't want you to do that. Is you're going to wisdom, right? I just want you to tell. You are then trying to apply that knowledge. I just want you to tell what the knowledge is. Now, you might think that the knowledge is obvious, but until you actually tell me what the knowledge is, you know about electricity generation, that is wisdom, right? But just tell me what it is. What can you say about the rainfall? But thank you for participating.
Sir, Colombo has the highest monthly rainfall in October.
Okay. The highest monthly rainfall in October. Okay, that's very good. Okay, Colombo rainfall. Okay, highest monthly rainfall in October. Now, anybody else who wants to say something slightly different or even challenge that?
Sir, excuse me.
Yes.
Yeah, it shows the variation of the rainfall throughout the year.
Of course it does, but I want some knowledge about it.
There are 2 peaks.
Okay, that's very good. So somebody said earlier that Colombo has the highest rainfall in October. So that is good. That is good. But if you say that, you completely miss the fact that Colombo has almost the same highest rainfall in May. So you can see that nicely. Colombo rainfall and actually Candy rainfall is not quite like that, but Gaul rainfall is also similar. It has a double peak, right? Double peak. So that's very good knowledge, right? So of course we know this. I mean, these are the intermonsoon rains and things like that. This is a very simple example. But there might be some data in what you're researching in which you cannot actually see that. In which you do. Okay, right. 2 main rainy seasons. I can read from the chat. Yes. Okay. Then of course somebody was talking about electricity generation and things like that. So let's go to that. Okay. Sorry, I cut you off. What were you going to say? The person I think who spoke first.
No, yes.
Dry period.
Yeah, I'm just saying that because the first quarter we must be ready because no rainfall. Therefore, maybe you need to go for thermal generation or whatever others.
Okay.
Therefore, definitely we know.
Right. Okay. Thank you for that. Anything else? I mean, it does not, you don't have to stick to thermal generation. It can be anything.
Yes, drinking water problem. And also.
Yeah. Okay. Right. That's right.
End of the year, the reservoirs are going to be completely filled. Therefore, that information is useful for
Right. Okay. Anybody else?
Sir, plan deep excavations in dry months in construction.
Okay, very good. Okay, deep excavations, and even if you are advising a friend when to build his or her house, you say do the foundations in January, right? Okay, right, excellent. Anybody else? Okay, yeah, go ahead. Right. Okay. Or if you are inviting a cricket team from overseas or whatever it is, so maybe you can do it in January, February, maybe March, or maybe July, August during that time, right? Okay. So that's actually wisdom, applying this knowledge, right? So there are various other things. So you can see that, you know, the structuring is important, right? Now, I mean, I'm sure you will know this, of course, but, you know, there is no point taking all these numbers and doing a pie chart, right? There's no point doing a pie chart, okay? Now, this is something else that you can do. So you can go a bit more deeper into the data. Now, here, this is Colombo rainfall, and this is correlated for each month with the rainfall in Kandy and Galle, right? Okay, so what can you say about this? What is the knowledge you get before talking about wisdom, that is applying the knowledge? What is the knowledge you get from this?
Comparatively, Galle has high rainfall than Kandy.
No, this is a correlation between Colombo rainfall and, you know, this is Galle rainfall and Kandy rainfall, right? So, yeah, of course, you can say that also, I suppose, but it's, yeah, what can you say about the correlation? Anyone about the correlation?
When the Galle rainfall increases by 94%, rainfall in Colombo also increases. Right.
Okay, so you are being very accurate. Okay, that's good. Okay, so that comes from. Are you an engineer?
No.
You are not. Oh, okay. Right. Okay. Are you a scientist? I don't know. It's okay. Right. So you are being very accurate. So one of the things about these pictures, you know, like I have drawn, is to see the big picture, right? Okay. So far no one has told me what I actually want to hear, but that doesn't matter. It may be just the way that I look at things. Okay. So that's why research is interesting, and that's why, you know, we have things like conferences and papers and things like that, because all of us have the same data, but different people maybe, you know, structuring it, interpreting it, applying it in different ways. So we learn from each other, right? But I wonder whether somebody can tell me what I see from this picture. That may not be the only thing to see, but anyway, go ahead. Anybody?
Yes, sir. The intensity of the Galle is high.
Yes, somebody said that, but this particular graph is telling something else. What is it telling you? You can see the labels on the graph also. What does it mean?
The Colombo rainfall is following Galle rainfall than the Kandy rainfall at Kandy.
Yes. So Colombo rainfall is, you know, very, very correlated, right? So these correlations are very important, right? So when you're doing research, think about doing correlation. I mean, it's even for things like questionnaire surveys, right? I will talk a little bit about questionnaire surveys, but I'm sure other people would have talked about it. So you know, question 1 will ask you something, question 2 will ask you something else, but you know, for example, question 1 may be the age categories, right? Question 2 may be something about the months in which different people got COVID or something like that, right? But so very often you can report that, right? January these many cases, February these many cases, but very few people think about saying, okay, what is the correlation between the age group and the month in which they got COVID? You know, that kind of correlation, people tend not to do. I mean, over the years, I have seen students and people don't think of that, right? So Colombo rainfall is very correlated with Galle rainfall. So one of the things that I can think about is, I mean, I used to tell this to my first year students, right? I mean, nowadays, of course, you have AccuWeather and you can know what the weather is with a reasonable degree of confidence. But, you know, if you have planned a picnic or something like that, nowadays people, I don't know whether they go on picnics with their families, you get up in the morning in Colombo and you find that it's raining, right? And the distance to Galle and Kandy are the same, 72 miles those days, right? Of course, no expressway to Galle those days. So if you are wanting to go to a place that is not raining, then you will probably go to Kandy according to this graph, because Kandy rainfall, you know, will not follow the Colombo rainfall. If it is raining in Colombo, very large probability that it is raining in Galle as well. That is a simple sort of everyday, personal, family type of example, right? But there are a lot of things that you can get from data in this way. So, okay, before we leave this slide, you know, you have data like this. Now, this is some kind of processing. No, I mean, this is putting it in a graph. This is actually going a bit further and actually doing a correlation. Is there any other thing that you can do to this data that I have not done? It is also sometimes a useful technique when you're handling data.
Sir?
Yes.
So, Galle data are linear data.
Linear meaning?
Gradually increase. No, sir.
So I don't know. I can't say that from the data. Now, I'm not asking you to tell me what the data, I mean, you know, I'm not asking you to give me knowledge. I'm asking you to tell me how to structure the data. What can you do with this data? Here I have simply put them in a bar chart, right? What are these called? These are bar charts, right? Yeah. Is there something else that I have not done which you can suggest to do?
Average rainfall for roughly the entire country, half of the country, annual rainfall kind of figure.
What is it? This is the total.
Yeah, total. And if you average it out and
average this.
Average, yes, total of Colombo, Galle, and Kandy, we can get a rough idea about rainfall in Sri Lanka.
I am not sure about that because, you know, there is a dry zone and things like that. No, yeah, okay. Anyway, thank you for that. Anybody else, can you tell me what can be done? Somebody has put on the chat something. Project the distribution to standard deviation and mean, which will be very useful in decision making. Okay, somebody has suggested box plot. Okay, I'm not sure exactly what you mean by a box plot. I'm just asking for fairly simple things, right?
So cumulative value?
Cumulative, okay. Okay, I'll take that cumulative value. So each month you keep adding something very simple that can be done, which I think will give us useful information. Again, not many students and people do this when they are doing research, is normalizing, right? No one mentioned that. You divide, let us say, Galle and Kandy rainfall by the Colombo rainfall, right? So we can see here, actually, Galle rainfall is greater than Colombo, and then Kandy is the least. But if you divide by this, now here Galle rainfall for January will be something like 1.2, and this one will be something like 1.5, right? But when it comes here, it will be something like 0.9 because you divide 67 by 71, and this will be something like 1.1 maybe or something like that, right? So if you normalize by Colombo rainfall, that also will give us an interesting picture. I don't know what kind of knowledge you can get from that. If we did it, maybe some of you will come up with some good ideas. We may even be able to apply some wisdom on that, right? But, you know, first of all, you have to structure it, right? You have to process that data in some way. So again, it's a very simple thing to get ratios, basically, normalizing it, linear normalization with respect to maybe one of the cities, right? So I am now commending to you some of these techniques, right? Okay, right, okay, right. Let's go to the next slide. For some reason, always I seem to have to do this. Now, this has something to do with prior knowledge directly, right? So this is another exercise. Please, oops. Oh, what did I do? I have done something. Right. Can you see my screen? Prior knowledge and base rates. Yes.
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 Right. Right. Okay. Okay. So I will still value your feedback on this to answer these two questions. Right. So the first one is from a book by Daniel Kahneman. Very good book. I recommend for all of you. It has sort of overtones of this, artificial intelligence, connectionist methods and sort of, what shall I say, rule-based methods, but he calls it thinking fast and slow, right? I'm not going to tell you about the book more than that, but how would you answer this question? An individual has been described by a neighbor as follows. Steve is very shy and withdrawn, invariably helpful, but with very little interest in people or in the world of reality. A meek and tidy soul, he has need for order and structure and a passion for detail. Is Steve more likely to be a librarian or a farmer? Can you answer that question? So this is in the US, right? Taken from somewhere in the US. Okay. Anybody wants to answer that question?
A librarian.
Librarian. Anybody else? I would like a few answers.
Librarian.
Librarian. I saw at least one librarian of this call, so there may be other librarians also. Anybody else?
Farmer.
A farmer. Who said farmer? Did somebody say farmer?
Yes, sir.
Okay, why did you say farmer? You're probably correct, but I would like to know why you said farmer.
He loves environment than the people.
But he doesn't say that here.
Yeah, but it feels like that. People are in the world of reality.
Oh. He has very little interest in people or in the world of reality.
Yeah.
So you're saying that the environment is opposed to reality. Okay, that's one way of interpreting this, I suppose. Okay. Any other comments before I move on to the next question? Any other comments about whether Steve is likely to be a librarian or a farmer? Okay, somebody on the chat.
Yeah, because he also say he has a need for order and structure, because with the farming that he wants to keep his things in order.
Oh, okay, the farmer, right? Okay, so
and a passion for details.
okay, I will give you the answer in the next slide, right? Okay, but anyway, I think he's Banduni, he's making an impassioned plea for him to be a farmer. But let's have a look at the next slide. But before we go, I want you to answer this question also. So I don't know, probably there is no one from the health sciences. No, I don't know whether there is anybody from the health sciences, right? Suppose a test for a disease has a false negative rate of nil. False negative means nobody who has the disease will test negative, right? If you have the disease, definitely you will test positive, right? The false positive rate is 5%. 5 out of 100 people who do not have the disease will nevertheless test positive. Right? So if you have 100 people who do not have the disease, even though no one has the disease, 5 people will still test positive. That's a false positive rate. All of these tests have this false positive, false negative. You need to know that, right? Then 1 in 1,000 people actually have the disease, right? 1 in 1,000 people on average have the disease, right? You give your patient the test and the result is positive. What is the probability that your patient has the disease? Any answer? This one is a bit more complicated than librarians and farmers. Anyone wants to have a go at this?
95%.
95%. Right. Thank you for answering. Right. Okay. Right. Anyone else? Okay, somebody has said 2%. Right. Okay, let's have a look at those answers. So why did you say 95%?
Yeah, I just
yeah. So you are looking at the 5 out of 100 people who do not have the disease will nevertheless test positive, right?
Yes.
But that's worded in a particular way, right? It's worded in a particular way. That's not actually what that means, right?
Yes.
So maybe you need to be a bit familiar with statistical testing, right? So once somebody said 2%, is that why and why? That was on the chat. Can you unmute and discuss with us or what? No, you don't want to share why you said 2%? That's correct. That's correct, actually. Actually, this is from an article by Peter Lipton, very brilliant philosopher of science who unfortunately, died quite young, soon after a game of squash at Cambridge University. In an article called The Truth About Science, which was part of what is called the Medawar lecture in the philosophy of science. Yeah. So, so he said this was administered to a group of Harvard teachers and students, and a large number of people said 95%, but that's not correct. So the thing is, what this slide is trying to convey is the idea of prior knowledge, right? So this is one aspect of prior knowledge, okay? And I will tell you how that is important very much later in the presentation, right? Okay, so now the prior knowledge with respect to the first question is the relative amounts of farmers and librarians in the US, right? So there are 5 times as many farmers than librarians in the US. So of course you did not know that, right? You did not know that, okay? So if you know that, then even though a person, is very tidy and, wants to always work with books and things like that, the chances are that he might still become a farmer, right? Okay. Because there are maybe not enough librarians jobs available, right? And the tendency is that many more people become farmers than librarians. So that's the thing about prior knowledge, right? And also called base rates in statistics, which is indicated in the next the next question. So 1 in 1,000 is the base rate, right? So one way that you can look at it is to say, so actually you can use Bayes' theorem on this for some of those of you who still remember Bayes' theorem, right? Actually, I also had to look it up, but a common sense way of doing it is, okay, suppose you take 1,000 people, right? Out of 1,000 people, only 1 will have the disease, right? But if you test 1,000 people, 50 people will test positive, because that's a false positive rate, right? Out of 1,000 people, 1 will have the disease, but 50 people will test positive, right? So if you test positive, then the person who has the disease will test positive, and 50 others also will test positive. So the chances of your having the disease is 1 divided by 51. So that is 0.02. The base rate is 0.001. Okay. So if you test positive, it does not mean you can ignore it, right? Your chances of having the disease, or your patient's chances, have increased significantly from 0.001 to 0.02, but it is nowhere near 0.95, right? So if you look at Bayes' theorem, it says probability of the disease given the positive test is the probability of the positive test given the disease, right? Probability of the positive test given the disease is 1.0, because there are no false negatives. If you have the disease, you will definitely test positive. Multiplied by the probability of the disease. Now, this is the base rate, 0.001, divided by the probability of a positive test, right? probability of a positive test is what I just mentioned earlier. If you have 1,000 people, 51 of them will test positive, right? 50 people from false positives and 1 person from true positives, right? So if you do this, you will end up with 0.0196 or something like that, okay? But that's about prior knowledge. Now, now you might wonder, I mean, I did this also just to make this lecture a bit interesting, right? Of course, it's now about half an hour into the lecture, but I won't speak very much. I won't have this interactive after this. So the person in charge can ask everyone to unmute, to mute themselves or whatever, right? And I will go on like this, right? So one of the things about prior knowledge is, you know, what we learn from practice, right? Our experience of the world, right? Now I have given a few examples of these, right? So, so this is, you know, what I have called longitudinal corrosion. So occasionally people ask me to come and look at their construction sites and tell me to sort of find out what is wrong and whatever. So this was a rather unusual experience for me. You know, there was this corrosion, you know, close to, you know, where this concrete had stopped off, right? And after this, of course, I started looking at other sites also, and I discovered this. Certainly, of course, you can see this, you know, this corrosion staining, right? And of course, there is a crack right at the top here. So, you know, the consultant was worried that not enough cover had been kept and things like that. But if you look lower down, and that there was chloride attack, but if you look lower down, there is no sign of corrosion. There is enough cover and things like that. This is, of course, a marine environment, as you can see. Okay. So I call this sort of longitudinal corrosion, meaning that the corrosion appears to start here because this is exposed, right? And then, you know, there can be expansion of this bar due to that corrosion, and then, you know, it can crack like this. So we had an undergraduate project. There were 3 supervisors that the student had. He had a hard time, but I think he had just submitted a PhD thesis to Cambridge University. So he's not doing too badly. He hasn't been examined, I think, right? Okay. So we did something like, you know, this kind of, try to simulate this, the lab, right? So what I'm trying to say is that, you know, when you choose your research topic, right, you know, it can be sort of industry based like this, or, you know, if you're in a different field, you know, you can, you can think of what you have experienced in the world, right? And those can always be sources for doing a research study. So I said, when you do research, you have to take a slice of the world, right? So this is not taking data from here, but trying to recreate the world here. Now you cannot recreate the world exactly, because now, you know, we ideally we want to have a reinforcing bar, and we want to put it in a bit of concrete like this and subject it to a chloride environment and see whether, you know, there will be this cracking, right? But in order to study this, you want to think about some expansive pressures. Now, if you have a reinforcing bar, it is difficult to do that. So instead, what we have done is we have taken this kind of a pipe, a steel pipe. The moment you take a steel pipe, you can put strain gauges inside the pipe, which you can't do in a reinforcing bar, and then you can measure the sort of radial, circumferential strains, right? And then, yeah, the circumferential strains. Okay, then you can model it numerically, you know, thinking that, you know, there is a little bit that is cracked here, and then you subject it to some kind of, you know, actually you subject it to a simulated expansion, and then you find what part of the concrete has exceeded the tensile limit, and then you remove those elements and you keep going, right? Now, of course, you know, this agreement between the model and the experiment looks very nice. But if you look in this paper, this is only taking, you know, at one particular age, right? At one particular age, there are different ages, no? So it looks very nice. But at other ages, we did not get, you know, this, you know, we did not get such a good match, right? But you can see, you know, this is the top. So clearly there is more corrosion there. But you get some patchy corrosion here as well. So, you know, in the lab, you can't simulate exactly what is there in the world. you don't get the results that you expect all the time. And also you cannot, like I said, instead of a bar, we are using a pipe, right? But the main point in this slide is to say we can get ideas for research from things that we encounter in the world, right? Okay. Right, now this is another one about plastic shrinkage cracking, right? Those of you who are civil engineers on construction sites will know this, right? These are not serious cracks, but of course they are unsightly and they have to be treated, right? When the concrete is in its fresh state, you have random cracking on the concrete surface like this. Underneath, you find that the cracks have penetrated through this because this takes place before the concrete actually hardens, right? So these ready-mix concrete suppliers used to often ask me, to come to their construction sites and, give recommendations and things like that. So I thought, okay, this is worth doing some research on. Okay, so once again, we tried to take a slice of the world. Now I had to simulate things like, because in the literature it says, this is affected by sunlight. It probably happens between 10 a.m. and 3 p.m. So it's difficult to impose heat. So I just use some 200-watt bulbs like that close to the surface, right? And then to simulate wind speeds, which also create this, I used fans like this, right? And then, of course, in order to make this cracking happen, I could not use the actual concrete, but instead I used the mortar component of that concrete so that it will be a bit weaker, it will be a little bit thinner, and it is something that is manageable in a lab, right? So then we measure the total crack width, cracks tend to occur like this. And we can see now what we are doing here is doing some kind of sort of parametric study on, what conditions are likely to cause the greatest cracking. So if you think about the environment, when both the lights and fans are on, you get a lot of cracking. When you have only the lights and no fans, that is X means no fans, you have less cracking. When you have only the fans but no light, you have less cracking. And when you don't have any lights and fans, you have very little cracking. So clearly environmental factors are important, right? I mean, it is known like that in the literature, right? But this is just, a confirmation of that, right? Then typically those days people used sort of retarders and AI entrainers, So once again, this is an indication about, when you have retarder and an AI entrainer, then you, have different degrees of cracking. And this is not a lecture on plastic shrinkage cracking, right? But this is just to indicate that, okay, you have a problem out there in the world and you can come and investigate it. In the process of investigating it, we cannot simulate the exact condition, right? We cannot simulate the exact conditions, right? I mean, if you want, you can take it outside rather than doing the test inside, but then it's very difficult because you have to, measure things like evaporation, right? Time for evaporation to exceed bleeding, right? So you have to, measure the bleed water, measure the evaporated water, you have to have, I think in this case, we had an electronic balance and we had another small specimen here from which the water was evaporating, and we were able to measure the rate of evaporation, right? So we cannot simulate the world exactly as it is, right? But the main thing is for the purpose of this talk, the prior knowledge here is a knowledge of the problem, right? So research involves, a rich, it involves having a rich set of problems, right? Okay, so maybe we do not want problems in the world, right? But it is because the problems are there, whether it is economic problems or technical problems or whatever problems, it is because problems are there that we can do research in order to tackle the problems, right? So all over. And sometimes engineers, without doing the research also, you are asked to tackle the problem. So that's why engineering is called a problem-solving discipline, right? So, okay, let's go on. So 2 examples of getting ideas from the world out there, even though you cannot simulate the world exactly, right? Now, this is something that, this is like, I suppose I would have to say a bit of a hobby horse of mine, meaning this is something that I'm interested in as a researcher, right? I don't know. I mean, there are large numbers of you attending. So I would like to promote this idea also, this idea of analogical transposition, right? Big word, but and in this particular thing, you don't get very much of a, I don't know, output, but anyway, I will describe it. You can think about it, right? So, since the 2004 tsunami, I have been working on things like tsunami resilience, right? So the whole question of resilience has, anyway, become very important in the world because, this whole question about, increased natural disasters, then various other stressors on the environment. I think Banduni was talking about the environment, whether it is waste or plastic or carbon dioxide or various things like that, right? So we want systems that are resilient, right? Now, it appeared to me that, this word resilience had almost been associated with the ecological move, right? But if you look at the literature, the first reference to resilience is from structural mechanics. So resilience is actually the area under this stress strain curve, that is resilience. Actually, we know that many structural materials have ductility like this as well. So the area under this or this entire area is actually called toughness, right? So whatever it is this, the area under the stress strain curve that can be loosely called resilience or resilience plus toughness, right? Now, if you think about structural resilience, right, there are three inputs to structural resilience. One is, of course, you need redundancy, then a system will become resilient. You need robustness, meaning it must be well formed, then you have better resilience. And you have this ductility, very, very important concept, right? So if I think there is a paper that, one of these papers referred to here, the one in Mercon, I think, right? And Sahan Viswakula helped me with this. So we did some various, simple sort of exercises about, if you divide this into two, this will be redundancy, and then, comparing stress strain curves using sort of assumptions, right? And we found the areas under this curve, and we can think about, now this is a situation where there is no ductility. You have a stress strain curve like that. This is, of course, where you have high ductility, where, you have a plastic region like that. But we can think of a stress strain curve which goes up and comes down as something like medium ductility. And you can have, split into two like this redundancy. So you can see that, this area under the curve, which has again been normalized, like I mentioned earlier. So you can have high ductility will give you high resilience, and high redundancy also will give you resilience, right? So now you can transport this back, this analogical transposition, like I was saying, to various other fields, right? Now I have already seen a paper like this, about a system in Malaysia, right? A system in Malaysia, which is called a smart tunnel, right? Stormwater management and road tunnel, right? So when there are no storms, this particular tunnel is allowed to take vehicles also. When there is a yearly storm, the vehicles can still go, but this drain, right, under the tunnel that is full of water, and it transports rain. This is in Kuala Lumpur, right? Very high rainfall city. But once in about maybe a few years, you get a major storm, and in which case the traffic is, the tunnel is closed to traffic, right? So the entire tunnel is used for the water, right? So I thought this was a good conceptual analogy of, redundancy versus ductility. Now, using the tunnel in a different way. Now, if you think about this stress strain curve, you can see that here this is behaving in a different way, in order to capture high strains. Now, here also there is high rainfall strain, right? So the whole tunnel behaves in a different way because you do not have vehicles, right? So now the advantage in ductility like this, ductility within codes, right? This is not structural ductility, but I'm taking the concept of ductility from structures, meaning behaving in a different way under stress or strain, under strain primarily, right? So when you do that, and if you operate your tunnel like that, you don't need to have two tunnels, one for the rain, one for the cars, you see? So we can save a lot of infrastructure if we use this concept of ductility rather than the concept of redundancy. So that's a high level kind of, if you want to call it a research output, a conceptual research output, right? Now I have experienced this myself, this is Dehiwala, and I'm going in this northbound lane towards Colombo in morning traffic, right? So this is maybe last year or the year before. You can see that there is a vehicle on the other side of the road also going towards Colombo, right? Those of you who live in Dehiwala would have known that, right? Because in the mornings, 3 lanes are reserved to go to Colombo and only 1 lane is reserved to go to Moratuwa, right? So actually, this is not a bad thing. I mean, it's a bit inconvenient, sometimes a bit dangerous also, but for a third world country who is struggling now to pay off its foreign debt, right? It's not a bad idea. It's not a bad idea. It's about ductility, changing the behavior under high strain, under high vehicular strain, right? So here you find that there is ductility that is practiced, ductility conceptual, right? Of course, the moment you cross the Dehiwala Bridge, there is a marine drive as well as a Galle Road. So, you don't have 3 lanes going towards Colombo on the Galle Road beyond the Dehiwala Bridge, right? You have cars in both directions, here and here. Now, of course, they have extended this marine drive. And of course, it's very nice. My wife and I walk there almost every morning, right? Very nice place to walk on, right? But unfortunately, I think the country has paid a lot of money for that road. I'm not sure whether it's fully justified, right? Because now here also you have redundancy, 1 road here, 1 road there, and we do not need that ductility. Ever since this road has been constructed, I have never seen this kind of scenario. Right? So you might think there is progress, fine, progress, right? But then, as you know, we have had to experience sovereign default as a consequence of that progress, right? Somebody raised their hands, but I don't know. I think this may be turned off. Maybe you can ask your question at the end. I don't know. Somebody raised their hand? I can't see that actually. Okay. Right. Shall we go on? Okay. Right. So now this is another analogical transposition, right? So this has to do with, what shall I say? Structural mechanics, right? Again, and I'm borrowing from the field of statistics. Earlier, I used the field of structural mechanics to inform other disciplines, right? Now here, we know this formula, the most important formula you can ever remember, right? For those of you who are civil engineers, right? Maybe mechanical engineers as well, right? So now here we have the second moment of area, and where this y is concerned, right? We have the first moment of area, that is the distance from the centroid to the extreme fiber, right? So I always used to think about, okay, now in statistics, we have more than 2 moments of area, right? So we have the first moment of area, which gives us the mean, second moment of area, which gives us the standard distribution. But there is a third moment of area, which gives us what is called the skewness, and the fourth moment of area, which gives us what is called the kurtosis, right? So I used to wonder whether there were structural mechanics analogies for this, right? So actually, I have to acknowledge Isuru Nanayakara, who is now doing a PhD in Sheffield, right? And of course, Chintaka Mallikarachi was also involved in this a bit, right? So now, if you think about, this, what do you call it, eye sections, you find that this skewness is very well correlated with the rotation capacity. By rotation capacity, we mean this. Now, I have shown a similar graph like this earlier when I did ductility, but that is idealized ductility. Actually, the ductility will occur like this, right? This is the formation of the plastic moment, and this is, when it comes back to that plastic moment, right? So this region divided by theta p, this moment rotation curve, this will give you the rotation capacity, okay? So now, we can see that these things have meaning, right? And actually, if you look at this, and where this kurtosis is concerned, right, it is for closed section, right, closed circular sections or closed rectangular sections like this. So here the rotation capacity is correlated not with kurtosis itself, but with something called normalized excess kurtosis. Once again, I'm not going to go into detail because this is not a lecture about that, right? But it's just the idea that, you have these things in other disciplines. Can you, go from one discipline to another discipline, right? I mean, I think potentially that's a great way to do research, right? That's a great way to do research. So, you have various relationships like this for circular sections, for rectangular sections, for elliptical sections in the middle. So all fits very nicely. And also, practically speaking, normally we use what is called the section slenderness, that is d over h, diameter divided, d over t, diameter divided by thickness, right? So if you correlate rotation capacity with section slenderness, these are the correlation coefficients you get. But if you use our excess kurtosis, you get much better correlation coefficient, right? So this has actually some very practical engineering significance as well. The earlier one also has practical significance, but more at the planning level, right? Are you going to have two roads? Are you going to have one road and use that one road in a ductile, within quotes, manner under high strain or not, right? There's another example of this, the earlier one, in Rotterdam, in Rotterdam, their rainwater sort of discharge system, they actually use parks to retain the water, right? So, when there is a very heavy rain, those parks cannot be used by people, right? But, when there is a small amount of rain, then, there are various depressions in the park. So those become ponds, right? And of course, then the water is led away. And when there is no rain at all, then the park is accessible to children and people like that. But under heavy rain, then you can't use the park, right? So you don't want to have a separate, detention area for the rainwater and a park for the people as well. You do both in one, right? So you don't have redundancy, you save money, right? But you have to experience deprivation. Once in a few years, right? Okay. Right. So this is about so transferring knowledge. When you talk about prior knowledge from one discipline into another, right? Okay. Now this is about some research techniques, right? Transferring research techniques that you knew about earlier, maybe to a new area, right? Okay. So this is ANOVA, right? I don't know whether these techniques are also being done or whether that's not part of this course or not. But when I was doing my PhD 1982 to 86, this is my supervisor, Patrick Sullivan. Actually, he published this in 2004, but he was working on this with another student even at that time, right? So this paper is called a probabilistic method of testing for the assessment of deterioration, etc., etc. Basically, what it means is if you have a number of variables, right, you can study the relative influence of each variable. And let us say that if you have, maybe 3 variables at 2 levels, right, you have to actually maybe do 6 tests. But if you are clever, you can, and if you have 2 variables at 5 levels, right, then you have to do 2 to the power 5 tests actually, right? I can't remember now, 5 to the power 2 tests or whatever. Anyway, I was aware of this technique. So when I came back, returned in 86, so this was published in 94. So I looked at, I applied the same thing, right, for this mixed constituents and things like that, right? Things like, the mixed proportions, the mix, the slump, the amount of compaction, and the amount of curing. And you looked at strength, right? So this has to do with, it doesn't say what this is on, right? Strength and durability. I think this is on strength, okay? So this is also a good technique, meaning that, you find that the mix is very significant for strength, the slump is very significant, compaction is insignificant. So this can't be for strength. This must be for durability, meaning sorptivity, right? A test called sorptivity is having to do with the absorption of water, right? So you find here that you can get these 2-factor interactions also, right? In other words, curing becomes important, so curing is very significant, but also the mixed curing interaction is significant. So in other words, So if you have, so two different mixers, say, let us say, so this mix, those days volume batch mixers. So this water cement ratio is high, this water cement ratio is low, right? So curing is important for both these mixers, but curing is especially important for this mix, which anyway it has a low durability because water cement ratio is high, durability will be low, right? So if you cure, the influence of curing is much more important for this than it is for this, right? So so that means there is a mix curing interaction, right? A mix curing interaction. So the lesson from this is that, I don't know, people, you may be in different situations in different projects. So I don't know how many of you are just practicing professionals or actually in the research field. So if you're in the research field, then typically you will spend some time, right? Either in a higher education institute or something like that. You should not only be concerned about your own research, right? If you are thinking about a research career, you have to keep an eye open for what your supervisors, other research students are doing, or about what other supervisors, other research students are doing, right? Because then you can implement those ideas later on in your research career, right? If you are thinking about a research career, now I joined Morocco University in 1982. And then, of course, I finished my PhD research in 1986 and I retired in 2022, right? So a 40-year career, of which about 36 years were post-PhD, right? So you have to think about a lot of ideas for research during an academic career like that, right? So you have to get ideas for research, right? So prior knowledge is something like that. So this prior knowledge is coming from other people's research. Okay. So then very recently, so Chandana Kulasuriya did a PhD at Curtin University in Perth, and then his supervisor invited me also to co-supervise it. So we did not need to apply this ANOVA analysis, right? But then I suddenly remembered, I did this thing for this particular study. This was focused only on ANOVA analysis. This was focused on various other things, but we managed to do this ANOVA analysis to look at the various influence of different factors. I will not go to explain all of this here, right? So if you have used a particular technique before, then you can use it again, right? So I'm going to use, I think, another one of Anjana's research. But before that, originally, now this has to do with qualitative research, right? So some of you may be in qualitative research. This I did many years ago. I think maybe soon after the central bank bomb blast, that was in 1996, right? About what factors contribute to the vulnerability of buildings, right? So we looked at different case studies. We did not have case studies properly documented in Sri Lanka. Even if we did, the Ministry of Defense in Sri Lanka was not going to give it to us, right? But I made some contact with the Royal Military Academy in somewhere in the UK, and they were quite happy to give me their documents, right? So you look at these documents, look at the description of different events, and you find out what are some of the phrases that are repeated. So that's called data. And this data is not like rainfall data, right? Now, when you combine this data, this is called grounded theory, right? This whole concept is called grounded theory because it is grounded in the information, right? It's like you are generating theory from the data, So then, of course, you have slightly higher level interpretations of this data called interpretation. So, for example, reinforced buildings did not collapse. So, which means that reinforced buildings can withstand considerable blast. Masonry construction is weak against blast. So, this is a bit of an interpretation, right? And then from this phenomena, then we come across concepts like this. So the structural material is important. The structural connections are important. So that is not from this. I mean, there are a whole lot of other phenomena and data. I'm just giving these as examples, right? And then also separately, we can, plot these, I think these are phenomena actually, right? Which ones keep getting repeated so that you get an idea about which concepts are important. Advanced warnings are important, right? So this was about the IRA bombings, right? I don't know about, during the LTT time and things like that, but the IRA, I was also in London, studying from 82 to 86, very often they give warnings because they do not want to hurt humans for some reason. No? Maybe IRA, I don't know whether they changed or not, but very often the IRA bonds had warnings. So then, of course, the use of glass, very often glass was mentioned in these reports. And we experienced that in Sri Lanka also. More people lost their lives through glass than through structural collapse. Because there were not many structural collapses, although there were a few. So we can get, various insights from data like this, right? So right now, this is what I did. I'm not sure how I got this idea of grounded theory. Maybe a collaborator of mine in Bristol, one of his students had used grounded theory. So once again, other people's research, right, as prior knowledge. Okay, so that's one idea about prior knowledge, right? Then recently, once again, when Chandana was doing his PhD, he also did some questionnaire surveys, right? Here, these were actually reports, documented reports. These were questionnaire surveys. And the qualitative parts of the questionnaire surveys. Sometimes questionnaire surveys involve, putting various tick boxes against various things. I mean, okay, age between 5 and 10, 20 and 25 years, 30 and 50 years, and various things like that. But here, you have data like the way I mentioned, right? Now Chandana brought to the table this concept of integral theory, which is not a bottom-up theory like this. Now here you get the concepts or the theory emerging from the data. Now, if you think about this integral theory, already the top level is determined, right? It means that if you study any subject, there will be an individual subjective aspect, a collective subjective aspect, an individual objective aspect, and a collective objective aspect as well, right? So what we did here was in this research, we tried to marry integral theory with this grounded theory, right? So for the top level, we did not generate the top level from these, but these concepts that were obtained. Now here I have called it concepts. Here I have called it phenomena, or we actually, these are all done together with other people, right? Here we fitted in these concepts into these different quadrants, right? So once again, research done by other people to be aware of it. How do we apply to your own research, right? Okay. Right now, we get a bit more specific because prior knowledge has a lot to do with literature. Right? And I think you have already had a talk on literature survey, so that is good, right? I just want to make a few remarks about the literature. One is actually the way that you structure this literature. Actually, one of my papers, not all, right? I actually put a table like this as part of the literature review, right? But this, of course, is in a very narrow area, right? It has to do with this paper actually, influence of drying on concrete sorptivity. Sorptivity is has to do with the absorbing of moisture, right? So of course there are different ways in which you can dry specimens, different durations in which you can wet the specimen, different strengths and water cement ratios of the specimens, and different sizes, because sorptivity testing had not been sort of, what shall I say, formalized or standardized, right? And then you have the sorptivity, the absorption is linear with the square root of T, but for different duration, right? And then you can calculate the sorptivity. I'm not going to go into all the details there, but when you're doing a literature review, if possible, whether you write it up like this or not, if you do a table like this, then any reviewer of that paper, we'll see that you have a very organized mind, right? A very organized mind. Some time ago, there was a colleague of mine who was doing his PhD at the same time at Imperial College, and then later became head of department, very, very eminent concrete technologist called Nick Buenfeld, right? So at one stage in his supervision, I think every one of his students who, did this literature review, he also used it to train a neural network, right? So some of you know what neural networks are. It has to do with a mapping of an input and an output, right? So some of the inputs would be strength, water cement ratio, maybe the specimen preconditioning time, and then the sorptivity can be the output, right? So I'm just, giving you various ideas, right? So this is now using prior knowledge in a structured way based on the literature. But more than that, very often I find that, when people refer to the literature, it's only at the early stage of their either research thesis or the paper. Now, if you're writing a paper, of course, most times journals would expect you to write your literature review under what is called the introduction. So the introduction serves as where you do your literature review as well, right? Then you sort of say, okay, these are the gaps in the literature, this is what I want to do, these are my objectives, methodology, then results, right? So you plot your results. So one of the things, of course, in this one, so this is, I define something called a desorption ratio. It's the amount of water that is sort of, removed in the drying process, right? Because you can dry in different ways. You can air dry it, you can oven dry it, right? So irrespective of the method of drying, well, you can get a reasonable curve. I mean, it does not fit exactly R squared 0.749 for a polynomial curve, right? So that's fine. However, once you do this curve, it is always very good. And once again, referees will know that you are trying to locate your work in the general body of knowledge, right? Locate your work in the general body of knowledge. It's a very important concept in research, right? Because you're not trying to solve the problems of the world by yourself. You have to look at the literature to find out whether somebody has not investigated something. And then when you find something yourself, like maybe this curve, you have to see, okay, how about other people's work? How does it fit into this, right? So of course, I had myself done some previous investigations and some of those results I put in, right? I had not calculated the desorption ratio, but I knew the weights and things like that. So I could now calculate it because this desorption ratio concept emerged only when I was doing this work. And of course, I could not use every investigator because they also had not developed this concept of desorption ratio. That was, in a sense, my contribution to, my small contribution to knowledge or what it is. But this person had enough information for me to locate his results also, right? So you can then argue that what you have now discovered here, it's an empirical equation, of course, not theoretically based, right? But still it fits with a lot of other knowledge as well. Okay, so that's another way, to fit in prior knowledge to what you have, right? To what you have. Okay, this also is another important concept. Now I have to, describe the example, before telling you the concept, right? So I don't know, hopefully that is interesting, right? So this has to do with pulse velocity, right? Now this is like a pulse velocity means, you have two probes on either side of the concrete, right? You send an ultrasonic pulse and you measure the time and you can get the velocity. That gives you an idea about the strength of the concrete, right? Now, I did some work here where this was just on cubes, right? So you have wet cubes, you have dry cubes, there are different strengths. And then you get a correlation between the pulse velocity and the actual cube strength of the concrete, right? So this is published in the Engineer Journal 1991. So you can see there's a difference between dry cubes and wet cubes. Now, at that time, so this was interpreted by this fellow called Thomson, right? Who says that, okay, this is what is called a wet cube correlation, dry cube correlation, right? Now, actually, he was also talking about the difference between a construction site here, which is dry. This was the structure, actually. Here we have structure. And the cubes that you pass from it, cubes before it went into the structure, right? So these cubes are, of course, cured under wet conditions, right? And then just before you crush it, you can do a pulse velocity test, right? So in the structure also, you can get a core and do the test. And just before you do the core, you can do a pulse velocity, right? But you can see that there is a drop in pulse velocity as well as a drop in strength. Now, this drop in strength, hold on, okay, let me look at it this way. This drop in pulse velocity will occur because there is a difference between the wet cube strength and the strength in the structure. That is why, for those of you who are civil engineers, you know that, when we do a grade 25 concrete or something like that, when we do the design calculations, we do not use 25 in our design calculations. We use 25 divided by 1.5 because we recognize that the concrete in the structure is going to have a less quality. So you have a safety factor of 1.5. So you have, you know, a drop in strength because of that, right? Separately, you know, there is going to be a drying of the structure. So when the structure is dry, right, then once again your pulse velocity is going to get reduced. So associated with this drop in strength, there is a drop in pulse velocity, and associated with this drying, there is another drop in pulse velocity. So in the actual structure, your pulse velocity can be very low, right, because the concrete is dry, right, but the strength may be still reasonable. Strength may be still reasonable. Okay. Now this is a paper in the engineer transactions. Okay. It is a paper about, you know, my experience on in situ investigations of structures, right? So I have now shown these two curves repeatedly in this, and now this is this structure that I investigated, right? Now, if you know about non-destructive testing, now the actual test that you should do is what is called a core test, where you go and take a cylindrical specimen out of, let us say, a slab, right? But you can't be doing that in 25 places, right? Because then your slab will all be all full of holes. Maybe the slab won't collapse because you might have many slabs, but it's an expensive process and time-consuming process. So what you do is you take maybe about 8 or 9 cores, maybe 12 cores, say, right? And before taking each one of those cores, you measure the pulse velocity, right? So then when you crush those cores, you get a correlation between the strength and the pulse velocity. Once you have that correlation, now you have tested only 12 places, both with pulse velocity and with core strength. But once you have this correlation, you can test 120 places in the structure, right? Using pulse velocity alone, right? Just a probe like this, you know, on one side and the other side of an element, right? Once you get the pulse velocity, you can use this correlation to convert to strength. Right now, you know, when you do 12 points, pulse velocity versus cube strength, right, you cannot, you know, get the best fit curve as the correlation, right? You might argue this, you can ask questions later on, right? You should not get that, because based on the literature, we can see that, you know, the drying of the structure. Now this curve comes here because of the drying of the structure. So the literature tells us that there is a parallel shift in this curve. So your curve that you get may be something like that, or it may be something like that, but you ignore that. You ignore your current reality by saying that, okay, this has to fit with the existing prior knowledge. It's like that. You know, 5 times the people are farmers rather than librarians, right? Or that, you know, the base rate is only 1 in 1,000. So anyway, it is not very likely that people have diseases, and there's a false positive rate as well. You are trusting the prior knowledge, right? And you say, okay, I will do a best fit curve, but I will keep this constant, right? That will be the same as what I have here, 1.24. And this one I will find by the sum of squares or whatever it is. This parameter, you know, will be subject to statistical analysis, not both parameters, right? So that's another way in which prior knowledge, in a sense, dominates over your current experience, right? Now this takes us to, once again, now these are my interests, right? So I am sorry if I'm inflicting you with my interests, right? But you may learn something from this, right? So these are like 2 rather ancient examples, right? You know, nothing to do with engineering also, but to do with logic and scientific method, right? Now, what do we do with authorities? So I said prior knowledge that comes from the literature, that's authoritative, right? So sometimes this prior knowledge should be kicked out, right? But at other times, you have to hold on to that prior knowledge. What I did here was holding on to that prior knowledge and saying, okay, this is the slope that we have to use here, right? And I will keep this slope, but this number I will get by statistical correlation. So I will read this. Now, this is from a book by Chalmers, available on the internet in case you are interested in philosophy of science. What is this thing called science? Right? This is about Galileo, right? I read it. I mean, I can describe it, but I read it because it's very interesting to read. Galileo's first trial of strength with the university professors was connected with his researches into the laws of motion as illustrated by falling bodies. It was an accepted axiom of Aristotle, that is prior knowledge, right? Long time before Galileo, that the speed of falling bodies was regulated by their respective weights. Thus, a stone weighing 2 pounds would fall twice as quick as one weighing only a single pound, and so on. No one seems to have questioned the correctness of this rule until Galileo gave it his denial. Galileo said no. He declared that weight had nothing to do with the matter and that two bodies of unequal weight would reach the ground at the same moment. Galileo's statement was flouted by the body of professors. As Galileo's statement was flouted by the body of professors, he determined to put it to a public test. So he invited the whole university to witness this experiment, which he was about to perform from the Leaning Tower. This is the tower in Pisa. On the morning of the day fixed, Galileo, in the presence of the assembled university and townsfolk, mounted to the top of the tower. Nowadays, they don't allow you to go to the tower, carrying with him 2 balls, one weighing 100 pounds and the other weighing 1 pound. Balancing the balls carefully on the edge of the parapet, he rolled them over together. They were seen to fall evenly, and the next instant, with a loud clang, they struck the ground together. The old tradition was false, and modern science, in the person of the young discoverer, had vindicated her position. So here you can see, that, the literature, you should not always believe the literature. Sometimes you have to, right? So that's a bit of a balance. Okay, that's a bit of a balance. So this is an old example, right? Old example. I'll give you another old example, right? So I will not play this. This is a vacuum chamber where it shows. Can I play this in? No, it's a very modern experiment about a feather and a weight that are dropped inside a vacuum chamber, and how the feather and the weight fall to the bottom of this silo simultaneously. Okay, let me go on. So this is another interesting example, right? This is also from physics, actually, astronomy. So, up to a particular time, only the planets up to Uranus had been discovered. So you have Mars, Jupiter, Saturn, Uranus on the other side of the Earth, right? Outside the orbit of the Earth, right? Now, by this time, Newton had acquired a significant reputation, right? And people were using his laws to track the position of these planets, right? So the attraction of the planets to the sun and also the attraction of the planets to each other, right? Now, when they observed the orbit of Uranus, this open circle was where Uranus should have been based on Newton's laws. But the black point is where the actual observation was. And by this time, Galileo had made his telescope, and observations could be made quite easily. This is the 1800s, right? So here, they seem to coincide. Now, again, they are diverging like this. So the open one is the theoretical and the black one is the actual, right? So now people were beginning to wonder whether they should discard Newton's laws, right? Okay. But then there were 2 people, a fellow called Adams in England and Leverrier in France, who said, okay, maybe there is another planet outside Uranus, which we have not seen, right? Which is attracting Uranus. So since this is moving this way, now this is the orbit predicted by Leverrier, right here. So this planet should be on this side of Uranus, right? And here also it should be on this side. So like that, various predictions are made. So here, the actual position is ahead of the theoretical position. Here the actual position is behind the theoretical position. So those could be obtained if there's a planet like this, orbiting, of course, with an orbital angular velocity slower than Uranus, right? And that one would be influencing this, right? And Adams gave this kind of position. Now this is actually the real orbit, right? This is the real orbit. Okay. So what astronomers did was they trained their telescopes on this region and they actually found this planet. So there we find that Newton's laws were not discarded. So the authority was trusted, right? And then people thought, okay, there may be something wrong with their observations or assumptions that there were only planets up to Uranus, right? So this interplay between prior knowledge and current knowledge and the research that you're doing is a very important idea, right? So there is a subsequent story to this, right? This is Leverrier. When was he living? Okay, in the 1800s, no? 1800s, yes. So towards the end of his life, he tried to use this same concept to explain what is called the anomalous or the odd orbit of Mercury, which is very close to the sun, right? This is at the other end of the solar system. Mercury is very close to the sun, right? So he tried to use the same thing, and he proposed that there should be a planet called Vulcan between the sun and Mercury. And everybody was looking for Vulcan, right? By the way, I don't know whether you have read this, okay? But I have described it, right? So, but you know, on the other hand, everybody was looking for Vulcan. There were some false sightings of Vulcan, but you know, Newton's theory could not be explained to use to explain the anomalous orbit of Mercury. Right? In order to do that, Einstein's theory of relativity had to come into play, where because of the sun's influence on what is called space-time, space close to the sun is actually curved. Right? I will not go into a description of the theory of relativity, but you are having, you know, significant curvature of space-time close to the sun. And since Mercury is the closest to the sun, its orbit is a bit different to the other planets whose orbits can be explained by Newton's. Okay, so there you find that Newton's laws being, in a sense, replaced. Replaced meaning, I mean, for terrestrial problems, for all civil and mechanical engineering problems of the earth, we can continue to use Newton's laws, right? But we can't use it for celestial mechanics, right? Okay, then we have to do things like Einstein's laws and things like that. Okay. Now, how does this relate to research now? Now, this is some research that I did, right? About, you know, whether you trust the authority or reject the authority and things like that, right? So maybe many of you know that if you replace Portland cement with fly ash, many cement companies are doing that. Now, fly ash is also being produced in Norway, right? So it's getting rid of the waste, not all the waste. I think people around that may be having some difficult times, I think, you know. So anyway, a big debate with whether we should have another coal power plant or not. But, you know, the PFA part of it is being used, right? In fact, some of the PFA was used for the Lotus Tower, right? So the PFA is actually integrated into the cement, right? And that's called Portland porcelainic cement or something like that, right? Now we were asked by, you know, now this cement company is now called INSEE, I think, right? Earlier it was called Holcim, before that it was called Holderbank. So when it was Holderbank, only they asked us to do this, right? So you can see Professor Nanakar is has collaborated with me in a lot of this work, right? A lot of the concrete work, yeah. So now what happens is, now let us say that 30% in cement you replace with fly ash, especially early on, you're going to have lower strength. So the strength, now here you see the ratio, I talked about a ratio of rainfall, this is the strength ratio. So when you take ratios, you get interesting insights, right? So the ratio of the porcelainic cement strength to the pure OPC cement strength should be low at low ages. This is 7 days. This is something like 0.83. And then when it comes to 14 days, it gets close to 1. After, so at 28 days, it can be even equal or more, and then it can increase it, right? That is because, you know, the porcelainic, that is, you know, the this is the cement, tricalcium silicate or whatever it is in the OPC that produces this CSH plus calcium hydroxide. This calcium hydroxide reacts with what are called supplementary cementitious materials, that is PFA, or there are various others like blast furnace slag and things like that, and it gives you some more CSH, right? So one would express this to be increased monotonically like this. Monotonically means it continues to increase, right? But for 3 days, we found a change in the trend. So like this is like sort of, you know, Uranus's orbit, right? I mean, not as significant as that, obviously, right? But we all try to do a little bit in whatever we do, right? So here you have a very high ratio. How can that be, right? So we argued we could not do scanning electron microscopes and stuff like that to check. This was done some time ago, right? 2003, right? Scanning electron microscopes were available, but not accessible to us, right? So, you know, these fly ash particles are spherical particles, and it has what is called a defloculating defect, right? Defloculating means these are the cement grains, right? So all the reaction occurs on the surface of these grains. So these grains sometimes can get pasted together. So if you have this ball bearing type particles, it forces these cement grains apart. So now the water can react with this entire cement grain surface, and therefore, you know, you get a higher initial strength, even though the amount of cement is less, right? Because of this dilution effect, right? There is less cement because you have to, 30% of it is a fly ash, right? So that is why there is what is called this deflocculation effect, right? And then this all can also serve as nucleation sites for the deposition of the calcium silicate hydrate, right? So we sort of said our results. Of course, there were not many 3-day tests, right? And maybe it's not such a valuable finding because in a sense, there may not be much practical use of this, right? Because people are mostly interested in long-term strength, right? So one very practical example of long-term strength is, you know, occasionally, the 28-day strength fails, right? So you have grade 25. If you do all the calculations, the maximum grade you can assign is something like grade 24, right? But if you happen to have used 15% or 25% fly ash, then you can argue that 56 days or 91 days strength, you know, will satisfy grade 25, right? So it's always in this region that is practically useful, right? Time beyond 28, right? This one is not so practically useful, but it helps to bring understanding. It helps to bring understanding, right? And it is also, in a sense, something novel. We are saying that, okay, we have discovered something that is not the norm, right? So now all that is coming under both subjecting yourself to authority as well as challenging that authority, but doing it in a limited way. Okay, there may be questions on this, which I will take later. I'm getting close to the end now. Okay, now creativity. These are, again, various things that I have put down. So there may be some creative ideas that you have, and I will just give you 2 very simple experimental things, right? So it's nothing, not rocket science, but, you know, some time ago, I don't know, some of you may remember Professor Samantha Hettiarachchi, who passed away sometime recently, right? After the battle with cancer, right? But he was involved in coastal engineering and, you know, used this armor units, right? And because he was a good friend, he wanted me to do some structural impact testing, right? Which means that you have to drop this, you know. So this is not reinforced, right? Drop this from a height. Now this is about 100 kilograms, right? So to drop it, we found, you know, it difficult to think about a quick release mechanism, right? And a cheap quick release mechanism that we did not have to import and things like that. So we thought of this thing, right? Actually, it took me many months to think about this, right? Maybe some of you would have thought about it much quicker, right? So you have a chain like this with 2 loops. So you have to weld this, that's quite easy. And if you have this kind of hook, So this is in the locked position, and then you slowly turn it like this, and then you release it, right? So it worked quite successfully. So what I'm trying to say is, and I had a student also. I had a young student, a sort of an intern, sort of awaiting results, I think from Royal College, if I'm not mistaken, right? So all of us, if I'm not mistaken, he's a general manager of LECO now, right? Yes. So, this kind of interaction, maybe there was something that I have seen. So, so this prior knowledge is sort of like subliminal. You might think it's a new idea. I mean, that's great, right? Creativity, and we are asked to engage in creativity. But so this is another one, where you want to expose these reinforced concrete bars to a marine environment, and this one also is made of offshore sand, right? So there are some chlorides. So you want to see how soon this corrosion will take place, and we are checking it with what is called a half cell potential meter and things like that. But now if we were going to embed this in a small element like this, a cylindrical one, for example, then of course we would not have been able to use coarse aggregate. Similar to that other example I gave earlier, where for the plastic shrinkage we used only the mortar component. But this one we wanted to be more realistic, right? So we wanted to use the actual concrete, right? So then of course, difficult to vibrate concrete into a small cover zone. So we need a small cover zone also, because we wanted, while the project was going on, we wanted to call small cover zone, and we wanted to get some results, right? Because we had this cube with offshore sand and without offshore sand, with chlorides and without chlorides. So we thought that this was not a bad technique, so you have a mold like this, and then you have slots like this in order to put bars. So you can put either 4 bars, use 2 of these slots, or we did just 2 diagonal like this, right? So research involves this kind of creativity. Now, I cannot identify which prior knowledge was used in this, but the chances are that if you keep your eyes and ears open to what other people are doing, then these ideas will come to you, right? That's what I'm saying. Okay. Right. One last thing, I mentioned this earlier. Now this is a new theoretical idea about this excess kurtosis, right? So this, I have nothing to do with this, right? This is my student Isuru Nanayaka, right? So earlier there was a relationship between, skewness and rotation capacity for I section, right? But for hollow section, he used what is called excess kurtosis, right? The kurtosis of the section, I mean, you can get that, I mean, like a statistical distribution, the distribution of the material in this section, right? Minus, the kurtosis at a theoretical 0 thickness. I will not go into this, right? But this concept of excess kurtosis. Now, actually, I wanted to call Isuru and ask him how he got this idea, but actually in the literature, there is this thing about positive kurtosis, right? So now this is a normal distribution in dotted lines. So the normal distribution, by definition, has a kurtosis of 3, right? So this kurtosis, positive kurtosis, means higher peakedness or peakedness, if I'm pronouncing it correctly. It has a greater peak, right? And also it has fat tails like this, but peakedness is, I think, the main characteristic, right? So this idea of kurtosis in excess of a normal distribution is there in the literature, right? So maybe Isuru would have come across that as well. But here what he's proposing is kurtosis in excess of what is called a pure binomial distribution. Here you have all the material sort of located in 2 extremes, right? And this is the distribution of the material in this is probably like an elliptical hollow section, right? So this idea of this excess kurtosis for this probably may have come because, this difference between, say, any distribution like this and a normal distribution, right? So even these theoretical constructs, I mean, we come up with various ideas. Maybe, it depends on us keeping our eyes and ears open, to the knowledge that is there previous. Right. Okay, I'll finish with this one. Right. The years are going back to 1675. So prior knowledge. Isaac Newton is supposed to have written to Robert Hooke. You know both those names. Hooke, we get Hooke's law from, but Newton, of course, is the much better known scientist, right? He's supposed to have written to Thomas Hooke saying that if I have seen further, it is by standing on the shoulders of giants, right? Now, there are various stories about Newton, right? Some people say that he was a great, I mean, he's of course a great person intellectually, but other people say that he was rather a disagreeable person and, you know, had various disputes with scientists, including this Robert Hooke, right? So this Robert Hooke is supposed to have been a small-made person, right? So he's supposed, so one way of interpreting this is by Newton saying, okay, I have stood on the shoulders of giants, but you're a short man and I have not taken any of your work into consideration, right? So we don't know Newton's motives. Let's not judge him because this was done in 1675. But recently, the UK, which has a new king now, has put out a two pound coin, you know, with this engraving on the edges. Actually, I have some coins from England from some time ago, and you see on these coins, even the 1 pound coin, I think, certainly on the 2 pound coins, you know, you have various various phrases, like, right? So this one, standing on the shoulders of giants, is on a 2 pound coin, right? So I wonder whether any of you have a 2 pound coin like this. If you have a 2 pound coin and contact me, I will give you 500 rupees for it, slightly above the current. No, not 500 rupees, but I'll give you 1,000 rupees for it. 2 pounds. Okay, right. But I can't be getting too many 2 pound coins, right? So I will stop with that. Okay, right. So what do? I stop sharing. I know I'll keep this on. But if you have any questions, you can now maybe allow people to unmute or ask in chat and things like that. Okay, thank you.
Thank you very much, sir, for your very informative and very interesting presentation. And always we like to listen to you all the time because that, I don't know, it's not boring at all. And you are adding many interesting things to your speech all the time. And thank you so much once again. And now, dear audience, now it's time to ask a question. So the forum is open. You can unmute yourself and you can ask a question. I hope that you can unmute by yourself. Yes. Or you can raise hand. You can raise hands and then we can unmute you. Please go ahead. And also you can put your questions in the chat box. Yeah, the unmute is allowed, so you can unmute by yourselves and ask questions. Yeah, please go ahead. Otherwise, you can put your question into the chat box.
Thank you so much. Would you possibly get the previous lecture videos? I think you can. I was told that previous lectures videos also are available, and so probably this one will be available also.
Yes, you can have it in the IESL YouTube channel. Please go through that and you can have it. And also there's a one announcement. Tomorrow we don't have a lecture. And instead of that, in next Saturday, we will have another lecture from with the support of the foreign resource person. Yeah, overseas resource person. So the participant may be confused that where they have to ask questions because it's very...
yeah, so I was the only person who asked questions. I asked them questions at the start. Some of them gave good answers, yes.
So now, can you give some advices that how they can use this prior knowledge into their research? You have talked a lot, but sometimes in a very kind of a nutshell, you can give some.
Yeah. So no, it's like, I mean, I didn't actually know also what the actual meaning of that phrase was. So I have interpreted, right? So there are different sources of prior knowledge, right? You know, one is especially for engineering research, observing what is around you, problems in the industry, right? So that's knowledge. That may not be prior knowledge, but it's a source of problems, right? It's a source of problems that can generate a research topic. And that is one. Then, concepts from other disciplines. That's like from that statistics example, and also the resilience example, right? Then of course you have examples from research techniques from your own previous work or other people's work, right? So you have various things like that. And then of course literature. I think prior knowledge will largely refer to the literature, right? So one thing is finding gaps in the literature, structuring your literature correctly. Then also, once you get your results, comparing your results, with the general body of knowledge, right? And then deciding whether the general body of knowledge is something that you have to fit into, or whether it needs to be altered in some way, right? Maybe you will not alter it in a big way, but in maybe even a small way, like that, the ratio, in the PFA example that I gave, right? Okay. Somebody is asking me about, is it mandatory to do a MSc? Can we proceed with the PG dip? So you're asking whether, yeah, I think it depends on various bylaws, right? Various bylaws. I think if you have a first class or maybe even a second upper in your first degree, many universities will allow you to directly do a PhD, right? If you don't, then maybe you need to do an MSc, right? That's the information that I have. Postgraduate diploma may not help, but MSc will help. If you have a second lower, for example, or even a general pass. With a general pass, maybe you will be allowed to do an MSc. Not 100% sure.
Sir?
Yes.
Sir, thank you for your presentation. The question is, now you are talking about comparing our results with the general body of knowledge.
Yes.
So in our this we will be doing in our chapter discussion chapter.
Yeah, okay. So, results and discussion. Yes, okay.
Results and discussion. So are there any method that you propose us to know, because in the state of the general body of knowledge, there may be similarity or controversies.
Yeah.
So to evaluate this and how to put it in the writing. So are there any general formats? So do you recommend how similarity, how to put it up? Or
yeah.
how
well, I gave an example of similarity where if you have a plot, you can just put a point in that plot to represent somebody else's work, right? Okay, there, sometimes there may be differences. So if there is a difference reported, then you might have to indicate why the different conditions under which that particular experiment was conducted generated that difference, right? You might have to do something like that. Okay. Is it helpful?
Yes, sir. Yeah.
Yeah. I didn't sort of prepare for this, but I don't know whether there is whether I can give you an example. Let me see. Others can ask questions meanwhile, but there seems to be a shortage of questions.
Yes, please ask whatever the questions you have, please clarify. This is a good opportunity to you to get good answers. Even in the previous lecture that you may not ask some questions, but Ahmed Mature sir is able to answer and give you very sensible answers. Please go ahead, and you can type your questions in the chat box. Even you can direct your questions shooting to the chat box to sir's one.
Sorry, I tried to find an example in something that I had written, but I couldn't really find it. Yeah. Sorry about that. Somebody has said, can you mention different review research and comprehensive review? Difference of review research and comprehensive review. Right. Okay. Not sure exactly what you mean, but I think there are two types of reviews, right? Now, many of you probably do a literature review. So if you're doing a PhD or whatever it is, right? Now, occasionally, you can try to get that published as a review paper, right? But that's not so easy, right? Normally, before you publish a review paper like that, you have to get the permission from the journal that it will be acceptable. Journals do not like to get review papers from every single PhD candidate who is doing work on their problem, right? What journals are more interested in is like state-of-the-art reviews by, say, very eminent scientists who have been working in the field for many years, right? So that may be the difference between review research and comprehensive review, right? But I remember I told you, I showed you that table. I showed you that table and referred to Nick Weinfeld, who at one time, tried to use his students' literature reviews to sort of, do something like, pattern recognition through neural networks, right? But even if you don't do that, right? If you are able to, in your literature review, structure it in this kind of way, maybe this way, and maybe a few other visuals like this, right? If you are able to demonstrate a very good appreciation of the state of the art in the field, together with your supervisor, of course, you will obviously need the help of your supervisor, you may be able to get it published as a review paper. Yes. So otherwise, it's normally for very eminent people. Okay. I'm not saying you all are not eminent, but okay. If the results of research was not in line with previous results, with the results we get in our research is enough to justify that the previous knowledge should be altered. That's what I'm saying. You can't, I mean, most of the time you can't. Most of the time you can't, right? That is why you have to sort of say that, like that example I gave, the 3-day strength ratio between pozzolanic and OPC. So then you give a reason why your work is different, right? And that may be something very valuable also. right? You give a reason as to why your one is different. Of course, you know, undergraduate students get treated to this in a sort of very small way when they do experiments. You know, they are told to, you know, compare the experimental results with the theoretical value and explain why the experimental results differ from the theory, right? So that's something that, you know, students are supposed to get some exposure on, right? So then you can say, you know, experimental error and various things like that, right? But when you're doing a proper research, maybe the experimental conditions, not so much the errors, right? Maybe you are trying to maintain something at 100% reinforced relative humidity and you couldn't quite do that, or, you know, something like that. Maybe something to do with the surface to area ratio in something that your one was different. Okay, right. Okay. Right. Then there is another question: how important is the use of validation of a model? If it is difficult to find any method to validate the results of a model, will it be an issue? Yeah. Sometimes validation is very important, right? So let us say that, especially if you are doing some kind of finite element analysis or something like that, right? Nowadays, of course, doing experimental research is going to be increasingly difficult because of our foreign exchange problems and all, right? You can still do computational research. You can still do computational research, but you need to then find an experiment described in the literature, you know, to validate your model, right? So that kind of thing you need to do, right? Or sometimes you can do some experimental work or even numerical work. Actually, there is some work that I did on, you know, the cracking of walls underneath reinforced concrete slabs, which are exposed to the sun, right? So there is expansion and contraction. We did some experiments also, but in addition to sort of validating our model against the experiments, the student also did a survey, right? Because these cracks are not uncommon, and there is a certain pattern that the cracks take, right? So typically they will be found at the end of a building. Normally they will be inclined from, you know, the roof, the slab, to the edge of the building, right? So then you can get your finite element model. You can look at the pattern of the cracks, and you can say, in practice, these are the crack patterns that have been observed, you know, in buildings that have these concrete flat roofs, right? So that's another way of validation. So it's not numerical validation, quantitative validation, but still that may be acceptable, right? So validation is an important thing. Every result you get, you have to say, okay, what kind of validation can I bring into this, right? You have to either say other people through other ways have arrived at this. Okay, I was doing something, I don't know whether Vajira is on the call, it's a current PhD, predicting deterioration rates, right? So for different building components, we predict deterioration rates. Then we say, okay, other authorities like in, you know, India, or I can't remember the countries, maybe in New Zealand or something like that, have recommended, have suggested that these are the, you know, lifespans of different building materials, and the values that we get, you know, fit into that, right? So, or if not the values, at least the difference in the values, right? You know, this is larger than that, the plumbing is less than, you know, the wall plasters and things like that, right? So those kinds of, you know, so when you have some results, always think, how does it fit into the wider body of knowledge? Because that is validation, right? Okay, there is another question: how to differentiate a okay, a lot of questions, and somebody has raised their hand also. Right. Okay, let me try to go through this. Right. What is the length of literature review? How many research papers in a research paper? Okay. Yeah, 20 papers. Yes. I mean, okay, so maybe that's a good number, but you can't You can't just read 20 research papers and do your research, because while you are doing the research, you know, especially when you get some results, then you want to find out have other people got similar results, right? So, so there was a quotation that once I think I had on one of my slides. Books are doors opening into corridors. You first open a door, wander along the corridors, and you find that there are yet more doors. You open some doors, some are trash, some contain exotic gardens, and some rooms have even more other doors, right? So you keep going on like that, right? So that's like research, okay? You know, because whatever you do has to be set in the body of knowledge. You can't read everything that they are reading also, right? But okay, 20 papers may be acceptable for a start. Or can you give some advice to practice how to explain about the data more deeper? I'm not sure how I can answer that question. I mean, I think I gave you some practical examples. You have the data, you have to sort of process that data. And it comes a bit with experience also, right? Correlations are good to look for, structuring it in some way, normalizing is a good way, dividing it by something else. Yeah.
Hi, sir. Am I audible?
Sorry?
Am I audible?
Ah, yes. Okay. Okay. So okay. This is a question from the audience directly. Yes, go ahead, Pradeep. Yes.
Yeah. Thank you very much. First of all, thank you very much for the, very interesting presentation, sir. I'm also coming from a civil engineering background. I've worked in the construction industry for a while, and now I'm working in education industry. And it actually, because of I have some IESL examinations and stuff, so that I need some time to work on myself on that. And at the same time, I'm actually thinking of starting my self-funded research. I don't want to sort of deviate from civil engineering, even though I'm working in the education industry right now. So actually, sir, I've started reading some topics related to structural health monitoring and stuff, so that I can sort of come up with a research idea. The question is I'm having, sir, is it okay to sort of use exactly like original methodologies some other researchers have used in their research?
Yeah, I mean, you can, sometimes, you don't have to have a new methodology every time. You can use other people's methodologies. You have to give them credit, of course. You have to refer to them.
Yes.
But the idea in a literature review is that you discover some gaps in knowledge, right? So maybe you can use the same methodology, but maybe it has not been applied to, some area or other, right? Maybe the areas of application have been limited, right? Then you can say, okay, this is going to be my contribution, right? I don't know. Does that answer the question?
Yes, I think so. Thank you very much for that.
Okay, somebody has asked how to differentiate a project and a research. I don't know. I mean, research is a fairly deep thing, right? You have to set whatever you're doing in the context of the body of established knowledge. A project is maybe mainly to, okay, let's think about that fly ash project, right? Okay. So when Holderbank were doing it, they wanted some mixed designs, to propose some mixed designs using what are called workable mixers, standard mixers, and economical mixers, where you use less cement even, right? Then because the idea is that, using fly ash will give increased workability, right? So that your total binder content is less, right? And compared with the standard OPC, right? So they wanted some very practical answers, right? So they did not give us funding for us to produce a magazine of concrete research paper. That was done later, and in some ways, that's a good question actually. In some ways, we did the literature review, or a significant part of the literature review, after we finished the testing, which is not good, right? Not good, but we still managed to get a research paper out of it, right? So that is because there is a client who wanted some information, right? So later on, when we went to see, okay, how does this fit in with what everybody was saying, we were able to do that. So that's the other thing about research. You know, research is not a linear process, right? So you go down one way, and you know, sometimes you might find that you know, you change the objectives also, because when you're doing something, you find that something is quite interesting, and then you change your objectives, and then you go and rewrite your objectives, right? You go and rewrite your objectives. So so it's not a linear process, it's a cyclic process. I hope I have answered that question also. About project and research. Okay. Can you elaborate relative to neural network research? What is the best way to find the reliability of an ANN model? Now, in a very technical way, an ANN model, you know, is validated because you use part of the data for training and part of the data for testing, right? So that is, of course, validating the model. And then, you know, the ones that perform best in the testing are the ones that you take as good models, right? But maybe greater reliability is, you know, if you are comparing an ANN approach with some other approach, right? Like some physically observed phenomena or experimentally collected data or something like that, right? So there is an internal validation, but also typically there should be an external validation as for everything, right? As for everything, you have to, right? You have to try and see whether what you are saying in your research is new, of course, is new, but it fits in with what other people have been saying using other kinds of techniques, right? And there may be some things which are completely new, right? Some things that are completely new, right? So that's how a research will work well. Can you explain the main difference when we write the conclusions part between experimental research report and project study report? Conclusions. Okay, I don't know. Not sure. So when you write the conclusions in an experimental research, you have to write very general conclusions, right? It has to be something that will add to the body of knowledge, right? You know, so there is no point saying that, you know, in a sense, you know, PFA, a replacement of PFA 30% gave higher strength than replacement of maybe 15% or 45% or something like that. Maybe you can say that, but you know, when you're writing it from a research point of view, you have to say that, you know, maybe 30% was the optimum replacement percentage or something like that. I can't think of a good example, but in principle, when you are doing research, you have to say things that are generalized. And don't write very specific things. Whereas for a project report, you might have to write specific. Okay, maybe I'm conducting the research on compressive strength of sawdust as partial replacement of fine aggregate. Can you please suggest a good place to conduct the compressive strength of concrete? A good place to conduct the compressive strength of concrete, to test it. There are many places that you can test, but I don't know whether you will have to pay for it. Good place to conduct the compressive strength of concrete. You know, if you are having problems accessing, what do you call it, well, experimental facility, right? What you have to try and do is to get somebody who belongs to some organization to be either a co-supervisor or a joint researcher or a collaborator. Then that person also will be interested. That person, if you're writing something, that person's name will also be included. And then that person will give you access to their lab facilities, generally speaking, generally speaking, right? Whereas if you just go and say, I just want to use your compression testing machine or any other piece of equipment, right? Then that may not work very easily, right? Because people are worried about their equipment. They will think if outsiders come and use the equipment, they may not look after it carefully. All those are also valid concerns, right? Yeah, I hope I have answered that question. Right. Okay. Shall we stop or what?
Yeah, thank you very much, sir. If there are no more questions, I think then we can wind up the session. And probably I may invite you once again in future, because there are several sessions, and I'd like you to come and talk to you, because I can see that the listeners are cities, and they like to listen to you. Though it's whatever the way you are talking, they like to listen to you, because every word is very helpful, very knowledgeable, and very informative. And so I think that you will help us again in the future for this particular certificate course. And thank you very much for accepting our invitation, because this, as you said at the beginning, this is a very new topic, but I hope that people understood what you are saying, because prior knowledge is very important when we are doing research, as well as when we are comparing and organizing, structuring, or as well as when we are writing in the scientific writing. It's very important. And so thank you very much once again, sir, for your valuable time spent on us. And sorry for troubling you time to time and asking such kind of lectures. But
No, it's okay.
You always,
as long as I have something to say, that's fine. Yeah.
Yeah, thank you so much. And so the participants, thank you so much for being with us for all this way. And tomorrow we don't have a lecture, but in the next week, probably Professor Dilanthi from UK will join with us. And also there are some international resource persons will be coming to this lecture series. So you will have a holiday on tomorrow, and so please prepare your research proposal. And then the next lecture will be on that, how to review a research proposal, that you may get the points of what kind of points the reviewer will consider of your proposal. And so thank you very much. Okay, have a good day for all of you. Thank you.
All right, thank you for asking me, Wanda. Thank you.
Thank you, sir. Thank you so much.